All
Ladies and
right.
gentlemen, look who decided to show up, Mr. Chris Saunders.
Is this
All right.
is this live?
We
This
are
is
live,
bro,
Oh
and
my
7
gosh.
minutes
live and
late.
for real.
I feel
It's
like I like the bars going on here.
Yes. Is that kind of cool? Like I don't know how I got myself in the middle though. I really want to be on the side. Let's try. There we
And I like Chris's
there we
ATP sweater. That's cool.
Yeah.
You're trendy.
Like that?
Another tech podcast. Check it out, people.
Yes.
It's good stuff.
Well,
That's
I don't know how prepared you got for this one, Mr. Castellani, but I even have my M1 Max shirt. Just
That's gonna cause some jealousy right there.
Just a flex on us that can't afford it. You know, the poor people.
So here's a comment of why here's a comment we got on Twitch of why Chris was a little bit late.
He's
metric.
clock.
It's true.
Chris is gonna love the 6 minutes of David and I talking before he got on.
Dude, I feel like I'm so zoomed in. Like, how do I get this thing to like back up? How do I back up?
Oh, it's cropping you, man. So all right, we're gonna move that. Welcome. Very first, I call this episode 0, so it is okay to mess up. The rest of the episodes will be perfect. I promise that to everybody that'll watch. So I'm John Owings, and this is the I gotta turn off the comments because I'm gonna be distracted by Bill. Here, let me put a different thing up. There we go. I'm John Owings. This is the unnamed, maybe Portworx TV, maybe something else, live stream about what we are learning when it comes to cloud native applications, Kubernetes, and all the data and fun that's on there. So I'd like to introduce these amazing people that are on here with me. We'll start with David, if he can just introduce himself and kind of how you got to this point in the world. In the world of containers. Let's not go all the way back.
Oof, I won't go all the way back. No, my name is David Castellani. I'm a cloud architect here at Pure Storage. I can say that, right? I'm allowed to
Yes.
Yes. Yeah, no, I started everyone same boat, right? We're all in IT, all been doing this, and then you see something about, evolution of virtual machines to virtual machines. You're like, ooh, that's an inflection point. And then it happens again with containerization, and then you have to pay attention to it. So came over from Red Hat, where the OpenShift is a thing, and that entire world over there is containerization. There are other products, but it's pretty much just focused heavily on containerization. So that's how I got here, focused on containers and Portworx.
Chris, all right, so
that was my cue. Oh, I missed the cue. Oh,
man. Step 2 is we transition to Chris.
Hey, everybody, my name is. Can we see who's actually watching? Are there people watching? I'll address it like
Bill's
it's a live. Bill, just in case.
Mr. Klein is.
There are three little head icons on Twitch. So. Awesome. One of those is me making sure it's running because it's on the other computer. So,
sorry, I bungled my own introduction. My name is Chris Saunders. I'm a cloud architect, also here at Portworx by Pure Storage. My journey was kind of similar to David's. I spent some time actually on the customer side, half my career. Although I'm getting old, so that balance is changing. But I spent a lot of time on the customer side, and then joined. This little company called VMware. They do a thing with like software and stuff. And then I spent a little bit of time at Red Hat. And I came here to join the team at Portworx for similar reasons. Like you see these inflection points in technology and you think, I need to be a part of that. So here we are, and storage is such an interesting point, I think, as we'll continue to get into. As far as Kubernetes goes and cloud native stacks, like the more I talk to customers and work with customers, I discover and rediscover that storage is at an interesting place in cloud native technologies. So I'm excited to be here.
I'm glad you're excited. Even though Bill just said this, storing is boring, but
storing is boring. That's the first, like if this thing takes off and there's a merch thing, yes. The first t-shirt is storing is boring.
Yeah.
Because it should be, right? Like it really should be. And I'm not saying that 'cause we're coming from
Can someone go to,
storage.
what is it? Not Etsy, or what's the one where you can make your own store real quick? You can sell t-shirts. Someone set that up. I'm gonna move this mode.
Oh, that's so much better.
Because I moved my head way too much. This is what the whole time Chris and David were talking, I was like, I don't stand still enough to be in a column. But I'll learn, I promise. So I'm John Owings. I'm the director for cloud architecture at Pure Storage, and I work with these guys every day when we talk about things. Now, just a disclaimer for anyone out there is this is not officially a Portworx sponsored thing, right? So we're here to talk about our experiences when it comes to cloud native and Kubernetes and all that fun stuff. But we're not, and a lot of that will have a lot of what we do every day because it's what we do every day.
Mm-hmm.
But it's not necessarily a marketing sponsored session, right? So hopefully that comes across that way, that we're here to kind of just share cool things that we're learning and doing. So yeah. Anyone else have anything else to add to this amazing intro?
The opinions expressed in the following podcasts are not necessarily those of Pure Storage or any of its affiliates.
And the comments are kept forever, Bill. Plot.
Yeah. It's one of those things like we're going to ask for forgiveness instead of permission.
Yes. Yes. And that will work great. So I feel like we're going to do a little intro. We kind of introed what we're going to do. We're going to have deeper topics as we go. But I think like a great way to kind of just intro, probably something that all of us do almost every day or more than once a day, is to kind of show what we do when it comes to Portworx and Kubernetes. So David was volunteered to do it right away and be the very first one. So we're gonna let David share a screen. We'll see how this flies. So he's going to share a little bit.
Are we going to be Portworxing? Is that what we're doing?
Portworxing. So hold on, let me put this thing here. Portworx Demo by David.
Oh, so professional.
Let's hopefully it shares correctly.
Yeah.
Boop, boop. Again, it worked before. It worked in pre.
All right. And then
we'll
remove that.
Boop. Cool.
Oh, which one do we want better? This one?
I like that.
That one. That one's good. I like it.
And if I need to pick my nose, I'll put it on this one.
I like the backgrounds in the terminal.
Or just pick your nose. Like, we're not going to discriminate here. Normal bodily functions is fine.
You can pick your screens, you can pick your friends, but you can't pick your friends' screens.
Yes.
Mine?
So I probably should have had slides or something to kind of go over what Portworx is, but I'm not going to. Right? We're doing this live. So for those of you on here, I'm sure Bill doesn't know what we're talking about, so I'll basically speaking to Bill. Portworx is a storage overlay solution that's trying to solve a lot of they're coming over from the legacy world, right? Virtual machines. You have to solve these storage problems when it comes to application. You have to answer questions around high availability and data resilience, and what are you going to do if? Well, those problems don't go away just because you're adopting Kubernetes, and in fact, some of those problems become even more complex. So what we're really talking about here is the difference between stateful and stateless workloads. So if you are having a use case where you need persistent storage and you've done something like deploying to maybe even a vanilla Kubernetes of your own design, or maybe you're in a cloud provider and you're using their CSI driver, you kind of know that if you played around in this area with persistent storage, it's a very painful thing. You're relying on an abstracted service that you're getting access to through an API. You don't have a whole lot of insight into what's going on. If that EBS volume attaches successfully, great. If it's times out for IO purposes, you're basically at the mercy of that provider. So what Portworx is trying to do is solve all these typical data questions around high availability, resiliency, backup, disaster recovery. And today the demo that I'm going to show you is what we call PX Migrate. So my Portworx brothers and sisters know this demo. They've seen it 1,000 times. They've performed it 1,000 times. But this is kind of to show one of the capabilities that a lot of my customers are asking us about. Like, how do we accomplish moving data around. Can we actually do that? Because one of the claims to Portworx is that essentially we care about Kubernetes, right? We don't care about the wrapper or the flavor of Kubernetes as much. So if it's OpenShift, that's fine. If it's EKS, GKE, AKS, it's all the same to us, right? At the center of all these platforms is still a Kubernetes API. And that's kind of where we interface. So what you see on my screen is 3 different panes. You'll see the top half says master 1 and the bottom half says master 2. So these are actually, if I do a kget nodes wide, you will see that we have 2 different clusters here. So what I'm going to be doing in this demo is I'm going to deploy a workload. I'm going to add some data to it, and then we are going to migrate it. And we're going to go from cluster 1 to cluster 2. And then time bearing, if there's time enough to do this, I'm going to go ahead and just do a quick autopilot demo as well, because why not? We're already here. We already have data. We already have a pod and a use case. So we might as well grow it.
Hey, for folks that haven't learned this neat trick, like, are you using the iTerm trick here to synchronize your? So if you missed it because he went quick, like you got 3 terminal sessions here, but you sent the same input to everyone. Is that a tmux thing? Is that the iTerm thing? Or
no, this is iTerm 2 on Mac OS.
Cool.
It has a broadcast feature.
Nice.
And you can selectively broadcast to a set of terminal panes, all of them, whatever kind of configuration you want. So it's very configurable. But that's what I'm doing because it just makes this process easier.
Cool. Yeah, I just thought if anyone's new to if anyone's watching this and they're just kind of getting their feet wet with Kubernetes, this is something that a lot of admins that we work with on the daily are using now because they're managing multiple clusters and nodes and things. And you can use distributed shell stuff, but this is a cool little feature.
I used to set this up. I used to do this all the time to set up 5 hosts at once until I learned how to use Ansible.
Yeah. That's where my brain was going. I'm like, you should never really be doing this outside of a demo or just testing something, learning purposes. But yeah, if you're doing this in production, you might need to reassess your tooling.
Well, troubleshooting and stuff, right? I was just on a session where we had, we were doing some troubleshooting, and the customer actually had 3 different sessions open to talk to the nodes and stuff. So it's a neat trick. Anyway, sorry, didn't mean to take you off the path.
Oh, no worries, man. No, this is fine. Interactivity is great.
I'm gonna have a commercial I'm gonna interrupt him with a commercial in the middle of it anyway.
That's fine. I mean, at this point, it's a live demo, right? So I'm still beholden to the demo god. So if this goes sideways, it goes sideways. One of the first things I want to show though is how we do this, right? How do we do the migration between cluster 1 and cluster 2? There's obviously, when you spin up clusters, there's no concept of connectivity between them or relationship. There's no relationship between these 2 clusters until you install Portworx, right? With Portworx, we have a bunch of CRDs. It's nothing new. One of them, though, is what we call a cluster pair. So I'm just going to show that real quick. So a cluster pair is essentially how we form the relationship between 2 clusters. Again, it's just a kind. So this is a CRD of cluster pair. And we're using a cryptographic key and certificate to kind of form this relationship. All I'm really doing here is specifying the IP address and my token, and this is how I can
David,
connect to these
one
2
quick
clusters.
comment. Can you blow your text up? Can you zoom?
Can I blow it up? Yeah.
Because there's people older than me trying to read that. Yeah.
Older people.
And I can't read it.
I'm at that exact point now where my eyes are going down, so I'm at the same thing. I got to respect my... Is that better? Can you guys see that? Hopefully it's coming through.
It's pretty
Can't
good.
read it on a 27-inch monitor. Just go crazy here, Bill. How about that, Bill? Is this readable now, Bill?
I can read it now, and I'm on a 27-inch monitor, so...
I'm watching on my BlackBerry, and it seems to be fine.
Your BlackBerry?
In Canada, everyone still has a BlackBerry.
That's right.
Everyone.
Yes.
So I have my cluster pair. This means that I have a one-way relationship between my master 1 cluster and my master 2 cluster. So this is how we form that relationship. So I'm going to do a quick deployment. I'm just going to deploy Postgres. There's nothing super crazy going on here. We have our storage class. For those of you discerning individuals, you'll notice that we have parameters here. So this is one of the cool things that you get with something like Portworx, is we can do replication of our persistent volumes. We do this synchronously across worker nodes up to 3. So we have a REPL factor of 1, 2, or 3. IO profile is basically how we coalesce data to disk. right? So we have different IO profiles. This should probably be, I think it should be DB remote actually at this point, but and then we can do tiered storage. So if you've got magnetic disk, SATA disk, NVMe in your machines, whether they're virtual machine or bare metal, however you want to bring that block device in, we can actually tier that storage. And then through your storage classes, you can actually make sure your workloads land on the type of storage your application requirement that you have. Allow expansion true, that's kind of a built-in Kubernetes thing. This just allows us to expand the volume right underneath the workload with no interruption. Then we have our persistent volume claim, which is just using that, oh, what happened to my shell? Which is just using that source class. And I don't know what's going on with my shell. All of a sudden, it's freaking out. There we go. So I'm going to watch my deployment on the second screen, which I know no one will be able to see. That's fine. And I'm just going to apply that YAML file that I showed you. So what's happening here is, the PVC is going to our storage class. Our storage class is set to use Portworx as its provisioner. And it's going to spin up the Postgres pod and grab a PV automatically. So we're already up. The longest part of this is always grabbing the image. So if you pre-populate your images, it'll be practically instantaneous outside of the actual initiation of the Postgres database engine. And so we have a Postgres pod up. There's really nothing in it at this point. So one of the things I like to do is kind of just show off what happens, if this worker node was to die, right? Because I just said previously, well, we have a replication factor. So in theory, what's happening behind the scenes is Portworx took the PV, put that on the same workload or worker node that the pod was running on, but it also created a volume on the other two worker nodes in my 3-node cluster. So what I'm going to show right now is essentially just coordinating the node that this is running on, which is node 1.3. So I can just do coordinate node 1.3, and then I can just grab my pod. And this is something that a lot of people, when they do something like this, they get scared, they get worried because, well, what's happening to my data behind the scenes? If you have the PV volume, set to delete, that data is gone, right? But I can do something like this. Whoops. Oh, I don't need this. XT. Oh, do I forget pod? Ugh. There we go. I can do something like this because I have Portworx. So what's happening behind the scenes?
You got to have all the words. All the words makes it work better.
All the words?
Yes. Hey,
okay, so you're saying,
interrupting you. Yeah.
Yeah, node 1.2 now. So notice we're on node 1.2. So this happened behind the scenes because Portworx can basically tell Kubernetes like, hey, the worker node you should reschedule this on is worker node 1 or worker node 3. In a larger cluster, again, we try to always init the pod on the worker node that has that replicated volume. If for some reason Kubernetes can't do that, we can init the pod on a worker node that doesn't have the replica and then network mount that. So you still have the availability of your data, but now you're beholden to the latency of the network. But that's usually not a problem. Most people are looking for data resiliency rather than just performance. So that's usually okay. They can always recover from that later. So I'm going to go ahead and uncordon that node because you never want to leave one uncordoned.
That was me taking a selfie
now let's do
of us on the TV with my phone. So, David, you'll never be able to do a demo without me distracting you. This is the way it's going to roll.
No, this is great. This is great. So now I've just gone into the pod itself. I'm actually inside the PSQL pod, Postgres pod. And I'm just going to go ahead and create a database. And then I'm showing you, this is basically just to prove out that like we're not, doing anything behind the scenes.
Nothing up our sleeves.
Nothing up our sleeves. We are actually doing this live. This is real data. I mean, it's not real data, but it's in the actual pod. And now I'm using a tool called pgbench, which will allow me to create, dummy data essentially, up to about 5 million records in this Postgres pod. So this does a couple things. It shows that we're actually able to read and write from this volume. It's an actual real Postgres deployment with a real pod, real DB engine running. And it also adds data to the volume because moving around essentially empty pods is not the most exciting demo. So now we can just go ahead and connect to that database. We can do our DT to show here are the tables that are in this database. We can do a select count from PG bench counts. And you can see there's our 5 million records. So this is, legit. Sorry about that. All right, so I'm also going to show a little bit behind the scenes here. So we can do so this is actually the volume itself. So one thing you'll notice in the /dev in the device path, we have a pxd directory. Inside that pxd directory, we actually have a virtual device mapper device that is actually the target destination for the data for your PV. So this is actually the volume that gets mounted into the pod itself. You can see that we requested through our PVC a 2 gig volume. We're at 805 megabytes consumed, leaving us with 1.1. We're at about 44% consumption. This will be coming into play later on when we do the autopilot. You'll actually be able to use these numbers to define when you want to do autopilot action. So that's one of the metrics we're going to use. I'm going to go ahead and exit out of this. So where we're at right now is we have a deployment of Postgres. We have 805 megabytes inside the database engine, inside of our PX demo database itself. But we still haven't gone anywhere, right? We're still on the first cluster. We haven't actually done the migration to our second cluster. So how do we actually perform a migration? Well, that is another CRD. So this is the kind of migration. This is basically defining how you want to perform your migrations. There is a second kind of migration called migration schedule. Again, if you want to do this ad hoc, you can just use migration. If you want to schedule this to happen on a schedule, you can actually attach a schedule to this migration as long as the kind is migration schedule, and then Portworx will just handle moving the data behind the scenes. Now, one of the things that Portworx is kind of universal across the board is we don't just care about persistent storage. Right, because for those of you that have been doing Portworx or doing containerization or playing around with PVs, you know that the volume itself isn't the only thing that matters. We also look at the namespace of the PV, and we look at the objects and resources in that namespace. So we actually migrate those as well. So in theory, what will happen is we'll move all the resources over as well as the persistent volume data, and then the pod will init on the other side and come online and consume that PV, but everything should be there to allow Postgres to run. So I'm going to go ahead and I'm going to apply this. First, I'm just going to set this up. Oh, I just lost connectivity, I think. I did. That's the best thing to happen in the middle of a demo is you lose connectivity. Oh, I'm on the wrong one. Why is it going to PX backup? Yep, see, look, I lost it everywhere. PX deploy, ladies and gentlemen.
5G. It's 5G issue.
Right.
Shut everything down.
Shut it all down. Frying my brain. So hopefully I'm still here. I'm still here. All right, cool.
Oop. Did you lose the node? Did the node go away?
No, the container on my laptop lost connectivity to the cluster. I'm going to put this up here. This is how it rolls. You just keep going with it, right? Just keep rolling. So what I did down here in the second cluster is I'm actually monitoring the namespace, but because we haven't performed the migration, there's no resources there yet. I also haven't applied the actual migration resource, so that doesn't exist yet. So now that we have all this set up to see what's happening behind the scenes, let's go ahead and apply this. So you can see that our object was created. I want to move this over a little bit. So it's in progress. So what's happening right now is Portworx uses object storage as kind of like a medium to do this type of a data transaction. So Portworx is actually going in now and copying the PV into S3 object store, chunking it up, and then it's also grabbing the resources and putting that metadata into object storage. Once that's complete, the destination cluster, which is down here, master 2, we'll see that that is done and then start pulling that data in, and then we'll init on the other side. So one thing that I didn't talk about though is some of these options that you have available to you. You're defining what cluster pair to use. This is what we set up earlier. Include resources. We always try to move the PV, and you can see this took, about 45 seconds to complete. So we're now online on the second cluster with the data that we created in the first cluster. And I'll show you that in a second. Include resources true up here in the top pane. This is basically saying, hey, we're going to move the PV no matter what. But do you want to move the objects as well? Start application set to true. This is saying, hey, you know what? We'll just leave this scale down to 0 unless you have start application set to true, and it's safe to allow that application just to auto start. So once the migration is actually complete, the destination cluster will just automatically init those pods. If you have this set to false, it'll look at from the source cluster to look at what you have as set as your scale factor for that deployment, and it'll use an annotation to set that for the other side so that Portworx on the destination cluster knows when it does get scaled up what it should scale to. And then lastly is our namespaces. So you can actually list a bunch of namespaces in your migration object. And this is something that you could do, just do one namespace, or you could do a list of namespaces so you can move a whole bunch of data at once and a whole bunch of applications. So now we're on the other side. We are in our destination cluster, and I'm just going to do a quick proof of that. So I'm going to go ahead and exec into the pod on my destination cluster, and then do the exact same thing I did on the source. So now we're attached to that. I can show my DT. There's my drop tables. I can do select count. There are my records. I could drop out of this and show you the actual. And there's my PXD volume. Okay. So this allowed us to go from our source cluster to our destination cluster, defining what resources we wanted to come over, and if we wanted to start the application on the other side. Because these two clusters, everything is self-contained, I don't have a problem doing that. When you might not want to do that is if you're migrating a workload that needs to make outbound calls, or maybe it's not yet set to talk to a database that doesn't affect production. You might want to leave that to false until you correct something like that. So that's my migration demo. Would we like to go into Autopilot?
Yeah, I mean, since you're there.
Since I'm
Why don't we see
here.
it?
What is an autopilot?
Yeah.
So Autopilot is a feature like PX Migrate.
Why am I thinking about the movie Airplane?
Autopilot.
Oh, yes.
All right, where is that at? Cool. So Autopilot is a feature from Portworx that allows us to monitor workloads, typically PVCs or PVs, and basically look for a triggering event that evaluates to true, an action that will take place once that triggering event evaluates to true, and then a limit. The limit is simply because you just don't want a tool, an automated tool like this to run wild, especially if you're using shared storage with other production workloads. Probably not a good idea to let your tool just have uncontrolled, scale and potentially consume all the storage on your array.
We work for a storage company. Consuming all the storage is a good thing.
Consuming, yeah, you want to consume all your storage.
Just let it go.
Just
Please
all
do.
that, yeah.
We can ship more to everyone out there. We can ship you more arrays. Just let it use it all.
Yeah, we got a raise. We got a raise on a raise on a raise, man. We're good.
But so the type of storage that we're talking about, I mean, you've got a Postgres database here. It has a PVC that's sitting there and currently at a certain percentage utilization, but like we can actually automatically expand the volume that is taking up space on a disk somewhere. But like we're talking about the PV, right? The actual Kubernetes object that is the storage that is sitting on a disk somewhere. I'm trying to connect some dots for the folks.
Yeah, you just give us block storage. Obviously, we prefer the Ferrari that is pure storage, but any block storage will do.
Yes,
I
almost want to say is that he's connecting the dots of like what you're going to expand here is the PVC or the actual volume within Portworx. We can expand the other, the external storage, right? The pool, but.
We're just focused on this volume right now. Yeah, that is true. We can manage and kind of do day two operations, not only for PVs, but like John was saying, for the actual storage pool that is underneath Portworx that rides on top of your block devices. We can actually do that too. bearing what cloud you're using. So if you're using vCenter, that's essentially a cloud provider, or one of the big three, works fine there. And we're always adding in more cloud providers as we, our customers demand it. So what I'm showing you on my screen right now is an Autopilot rule. Again, it's another CRD. This is basically just saying, hey, we're going to watch for a label in the namespace that we're deploying this to. Here's our condition that has to evaluate to true. So what this is basically saying is, hey, if the utilization of the volume is greater than 30%, evaluate to true. So once that evaluates to true, what happens down here at the bottom is we have a scale percentage. So what this does is this basically just doubles the size of the PV. So it'll go from 2 gigs, if this works, to 4 gigs. And then it has a max size of 30 gigs so that eventually it'll keep monitoring and watching. It'll keep growing it in a cycle. I think the default timeout's like 5 minutes. So every 5 minutes, Autopilot will reevaluate this PV. Does this still equate to true? And then take the action again, but it will always stop at that 30 gig limit. And so that's what we're going to do here, because we know our volume is at 44%. So what we should see happen in the background is Autopilot evaluating this this PV and then taking action. You can see right now it's a 2 gigs size. And then let's just watch this, because things happen pretty quickly, so I don't want you to miss it. Kubectl PXC, volume, inspect.
Speaking of Kubectl, have you used NerdCuddle yet?
I have not, but it sounds interesting.
That's our sponsored project of today.
NerdCuddle, because every nerd needs a cuddle.
Yes.
Yeah. Oh, that's yeah. I'm gonna shirt with that.
Yes. I can relate.
So what you see here is this is actually using the PX interface to our Portworx cluster, and we're just simply setting a watch on it. So every 2 seconds, it's going to refresh. But what we're really looking for here is once we apply this resource, once it gets evaluated to true, and then Portworx or Autopilot decides to take action, we should just see this flip from 2 to 4 gigs. So let's go ahead and get our Autopilot logs, because we should be watching that. Whoops, let me back out of here. Grab this. Yoink. All right, cool. So we see the log output coming from Autopilot. Once I apply this object, it's going to start watching. You'll see actually Autopilot recognize that the rule was added. And then it'll start evaluating. So there's our new rule with name Postgres resize right there. And now it's already met the condition. And so what's happening right now is basically Autopilot's trying to see, like, is this actually happening for a certain length of time, or was this just a spike and then it goes back down below our condition? And if it continues to evaluate to true for a certain number of attempts, then it will go ahead and perform the action for us.
I'm actually throwing this question up there from the chat. It's that Kubectl PXC plugin. Can we throw the link to that out there for people that don't know where it is? I know Bill knows where it is, but if anyone comes across this, is there, like, I guess there's a place we could post like show notes and stuff like that, right? Anyways,
yeah, as we mature, we can kind of figure that out.
If only somebody had access to WordPress.
Yeah, boom, there we go. So now you can see that behind the scenes, this volume went from 2 gigs to 4 gigs. And I applied the rule, but imagine that you applied this rule after, as part of your deployment of this actual application. So now you're covering that application's deployment with Autopilot. So therefore, think about at 3 o'clock in the morning, if this database volume was to get to your threshold amount without Autopilot, it would keep going, and you'd hit eventually 100% utilization. Postgres would essentially not crash, but not be able to read or write new data, and then more than likely your application would bomb out. But with Autopilot, this is a day 2 type operation. You would come in the next day and just see your alerting system say, hey, Autopilot took an action, and it went from 2 gigs to 4 gigs, and that's it.
Yep.
The application continued to run, and you're just going, okay, cool. I just need to, watch the volume. Do I need to talk to the owner to say, hey, if it's getting out of control? But this is great because you weren't woken up at 2 o'clock in the morning to answer the Seb 1 call about an outage in production.
It happened to me. That has happened to me. Like,
yeah, no.
Also, a real thing that has happened to customers, like this specific scenario, like for folks that may not be neck deep in Kubernetes, like I've had customers with this specific scenario. They have actually been woken up in the middle of the night because a PVC ran out of space. And it actually can depending on how your environment's set up, can take some time to actually troubleshoot and figure out like what's going on. Oh, my application is barfing, and now it's the standard operation stack thing where now you got to figure out, okay, the application isn't working. What's happening? Oh, it looks like something's happening with the database. What's happening in the database? Oh, it can't write. Oh, it's out of space. Oh, now what do we do? Right. So that all of that whole chain of that whole cacophony of tech nonsense is sorted out for you.
Exactly.
And the cool thing about what we did here was just at the PV level. But like I said earlier, you could do this to the entire storage pool that contains all of your PVs. So if you get to that instance where like, hey, I need to grow a PV, but there's no more storage, Autopilot can grow the entire bucket underneath all these PVs and then grow your PV itself. So again, as long as you have the capacity, to do this, whether it's through VMware or one of the big three, we can just grow those volumes for you behind the scenes, talking to their APIs if you give us access to do that. Or we can just add more disks. And again, this is all happening behind the scenes. As long as everything works correctly, you just come into the next day to see, hey, your storage pool went from 1 terabyte to maybe 1.5 terabytes or 2 terabytes or whatever you set. And then you'll see your PV for your Postgres database then grew as it was supposed to, because now there was enough storage for it to do that. Bill asks, how often does Autopilot check the capacity used? That is a configurable setting that you can define how often it should check. And then you can also define how long between actions it should take. So by default, it's 5 minutes. But if you wanted to set that to a minute, it would just evaluate and say, hey, the condition is still evaluating it's true. I'm going to grow again. You could also set how many times it needs to successfully meet your condition before it will take action. So you can set a longer duration there. So in case it's just a temporary blip, if you're noticing that pattern where, hey, the database pops up above the limit and then goes back down 30 seconds later due to some kind of, batch operation that's happening, then it won't do that action, right? But if it happens for, a minute and a half, maybe, okay, that's a serious, that's not normal. Let's go ahead and grow the volume.
And what do we use to check those metrics by default?
So out of the box, we deploy Prometheus with an operator. That's kind of comes out of the box when you install Portworx. It is an optional checkbox there. And then we can use that out of the box to check these metrics, to see the volume size, to see what's happening behind the scenes, and then allow us to make an informed decision. You can use your own Prometheus as long as you have it set up beforehand. You can use your own, if you're using like a federated Prometheus install, you can start having your Prometheus install start pulling data from Portworx, and then Autopilot can use that just like it would the one that we install.
Nicely done.
I would like to say, for the very first getting thrown in and having the 74 comments about the screen being blurry going on over here, David,
we'll figure that out. Thanks, man. Episode 2, we'll figure out why everything is so.
I might have to spring for the higher bit rate. I mean, I could control all that, sort of, but
all the bits.
We got to have more bits. I think 5,000 is what they suggest on YouTube. And I'm wondering if, because this is the 720p plan, if they throttle that some.
Yeah, maybe.
Because on my screen, it looks awesome.
Mm-hmm.
But if it hits over here, it's a little pixelated. So we'll fix that.
Is this where we ask for subscriptions? No,
yes,
wait.
Please, yeah, subscribe. send. I'm not going to say any. There's no tiers yet.
Do we need icons? Like,
how do we tip?
How do we tip? Yeah.
Kubernetes, yes.
Let me put
That's
my
a great name, by the way.
I'll put
That
my
is an amazing name.
Patreon account in here. I think we might know the guy.
Yes. I could throw my Cash App up, you know.
Oh yeah. Yeah, the official marketing team is going to be all over this. I can see it already.
Yes, especially if we start getting tips. They're going to be like, yeah, you got to shut that down.
They're going to get
let's not take tips. And luckily, this is I feel like this has gone fairly well for a very first run at it. Like if everyone can tell, like we didn't like rehearse. We did, kind of plan out that what we were going to do, but we didn't like do a complete run through offline.
Yeah.
I feel like it's pretty good though. Public commissions.
That's nice.
Yes.
It went really well for after Chris joined. Once he finally joined.
Yes.
Hey, listen, I need my copy.
He did. I didn't. So I said I didn't know, Chris. He asked like, "Hey, can I go get a coffee?" I didn't know you were going to go like.
Listen,
he got in the car literally.
No. I had to make the coffee. I mean, what am I going to drink? Like pre-dripped stuff, like an animal? Come on, we're not savages.
Yes, Chris has got an espresso machine for sure, like a high-end Breville or something like that.
It's nice.
I bet he does.
It's a Lally, actually. Thank you.
Ooh, that's like even higher.
It is. Breville's kind of in the middle there somewhere.
The beans.
Mm-hmm.
I thought about roasting, but anyway, that's a different stream. That's for the coffee stream later.
Yes, we can do that, but not today. Thank you everyone for joining. I am super excited that we had more than one person actually jump on and look. Yes, I do owe. By this comment, I was like, at first I was like, who is that? And by that comment, I actually know who it is now. So
Hey,
yes.
Yeah. So for folks that joined, thanks. But if you're watching this, because I think we're posting this afterwards to a few places, right? So like, definitely leave comments if there's anything that you want to hear. Like we are still figuring out what the kind of floor of capability is for folks that are watching. If you're watching for technical content, or maybe you're just watching for John's majestic beard, I don't know, but. If you're here for technical content, let us know what you're looking for. Is this too way up there? Would you like some more content that's like somewhere in the middle? Do we need to move a little bit slower? Let us know definitely what you think.
I think this right here is the base right here.
Listen.
I know.
Well, we're gonna have Bill on here too. We're gonna have Bill on here, and he's gonna.
Yes, we can invite more people. So,
for sure, all of you watching, you will be here eventually. We'll have definitely you provide some, because we all know that Kubernetes doesn't have a whole lot to it, right? It's super simple product.
It's easy.
Not a lot.
You don't need service meshes. You don't need load balancers. You don't need any of that stuff. It just works.
Point and click. Next. Ready to go. Deploy your apps.
That's what I hear.
Never any problems afterwards either. Not day 2 operations. Piece of cake.
So yes, please, like Chris said, put in comments, or you could find us on the Twitter, and I take comments there as well. And yeah, let us know what you're looking for, and we can't wait. We plan to do this regularly, so I will keep posting when it's going to happen, and then maybe eventually we'll have a schedule. I know David really wants one. So, all right. With that, I am going to. Here's what I'm going to do. That's what I'm going to do.
Oh, is it going? It's about to happen.
Oh, we're going to do the outro music. This is custom made outro music. Everyone,
the Chris Saunders.
All right. Thank you all. Have a good one.